Hello everyone and welcome back to my YouTube channel. In this video we want to solve for a and b. Given this problem, a squared plus 2ab plus b is 44. We are required to find all positive integer values of a and b. So to begin solving this problem, we need to have at the back of our mind that the values of a and b must be positive and they must also be integers. So positive integers, that's what we are looking for this problem. Now to begin, I'm going to make some adjustment to this problem. So I have 2ab plus b is equal to 44. Notice that I can factorize b from this problem here. So this becomes a squared plus b is common. Then I have 2a plus 1 is equal to 44. Now, going back to the conditions given, the values has to be positive and they have to be integers. If we make b the subject of the formula in this problem, we are going to have b is equal to 44. Transfer a squared to the right hand side, 44 minus a squared, and then divide by 2a plus 1. So this is our value for b. Now, taking note of the conditions given, first of all, a must be positive, and then b is also positive as stated. So for b to be positive, it means this fraction that we just got must also be a positive integer. So we need to look at values to put into a that makes this fraction a positive integer. For instance, the fraction, for it to be positive, the numerator either has to be positive and the denominator positive, or the numerator is negative and the denominator is also negative. None of them can have an opposing value. For instance, if you have negative up and positive down, the result will be negative, which will contradict what b stands for. Or if you have the reverse, it will still contradict what b stands for. So these are the only two cases that we need to examine. So starting with the first expression, that's the expression at the numerator, we have 44 minus b squared, minus a squared. What values can we put for a? What integer values can a attain to make this expression positive? Any number greater than 44 will make the expression negative, of course. If you say 44 minus 45, that gives you a negative value. So, and the number has to be, all of a square is definitely a perfect square. So if we put 7, for instance, starting with 7, you see that 7 squared is 49, and 44 minus 7 minus 49 is negative. We don't want that. Let us try 6. If you put 6 here, you get 44 minus 6 squared, which is 36, and 44 minus 36 is definitely positive. So 6 could be a value, and that's the highest value that a can have. What of 1? If you put 1 here as well, it's still going to be positive. So it means the value of a, positive values of a, has to be between 0 and 6. So we have a greater than 0 and a less than or equal to 6. So these are the two possible range of value for a. So between these values, we can have our a, and then we can test for each of these values to get our corresponding value for b. So let us now look at the various cases that we can have. Case 1. Case 1 will be when a is equal to 1. And when a is equal to 1, remember what our fraction is. We said b is equal to 44 minus a squared, then divided by 2a plus 1. And now when a is 1, b is going to be 44 minus 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3. This gives us 43 over 3. Now, if you look at this case, you see that what you get from here, although it is positive, but it is not an integer. So the fact that it is not an integer makes this case 1 unacceptable, because 43 divided by 3 will give you decimal values. Now let us look at a second case, case 2. And case 2, this is case 1. Case 2 will be when a is equal to 2. So putting 2 into this equation, the expression on the right rather, then b is equal to 44 minus 2 squared, then divided by 2 into 2 plus 1. So b is equal to 44 minus 2 squared is 4. 2 times 2 is 4 plus 1. This gives us 40 over 5. And 40 over 5 is 8, which is perfectly acceptable because it is positive and then it is an integer. So for case 2, our solution, which we just got, is a is 2 and b is 8, which is perfect. Let us go to the third case. We say case 3, when a is 3. So when a is 3, b is equal to 44 minus 3 squared divided by 2 into 3 plus 1. So this gives us 44 minus 9 divided by 6 plus 1, which is 35 divided by 7. And 35 divided by 7 is equal to 5, meaning that this case also is acceptable because it is positive and then it is an integer. So for this we say a is 3 and b is 5 is also acceptable. Let's carefully look at the next case. The next case is when a is 4. This is case 4. So when a is 4, b is 44 minus 4 squared divided by 2 into 4 plus 1. This is 44 minus 16 divided by 2 times 4 is 8 plus 1. This would give us 28 divided by 9. We are going to reject this because although it is positive, it is not an integer. This does not divide exactly. It gives us a decimal value, as 28 divided by 9 is 3.1111. So we reject this case as well and quickly go on to case 5. And case 5 is when a is 5. So let us test for the corresponding value of b. Here you have 44 minus 5 squared divided by 2 into 5 plus 1. This is 44 minus 25 divided by 2 times 5 is 10. 10 plus 1. So here you have 19 divided by 11. This also does not work because 11 does not divide 19 exactly, even though the result will be positive. So reject case 5 as well. And the last case, which is the 6th case, we say case 6, which is when a is 6. So the corresponding value of b will be 44 minus 6 squared divided by 2 into 6 plus 1. This is 44 minus 36 divided by 12 plus 1. This is 8 over 13. And as you can see also, this will be rejected because 8 over 13 will give us decimal values even though it is positive. So reject this case. So the only two accepted cases are when a is 3, b is 5, and when a is 2, b is 8. So the solution, the integer solution, the positive integer solution to our problem are a comma b equal 2 comma 8 and 3 comma 5. These are the only accepted solutions for this problem. I hope you have enjoyed this video. Kindly hit that like button and remember to subscribe to my channel if you are yet to do so, and I will see you in my next video. Bye.